All right, 7.1 is exponential growth and decay. So we're looking at the parent function for exponential growth. And the function we're looking at is f of x equals b to the x power, where b is greater than 1. So we may have 2 to the x power or 5 to the x power, as long as that b value right there is greater than 1. That is the parent function for the family of exponential growth functions with base b. The graph shows the general shape of an exponential growth. So looking at this graph right here, it's going up from left to right. So it is growing. That's why it's called an exponential growth. Down here at the bottom left, it talks about an asymptote. The x-axis is an asymptote of the graph. An asymptote is a line that a graph approaches more and more closely. So it will never, ever, ever touch the x-axis. It will get minutely close, but it will never actually touch it. It may round to 0, but it will not actually be legitimately 0. The graph rises from left to right, passing through points 0, 1, and 1b. So no matter what the b value is, it'll always hit 0, 1 right here. And then whatever the b value is will be the y value of this other coordinate, 1b. So let me move that up just a little bit for you. And then we talked about domain and range as well. The domain of f of x equals b to the x is all real numbers. So your domain is always all real numbers. And then your range is y is greater than 0. Not greater than or equal to, but just greater than 0. All right, now looking at exponential decay. The first one was exponential growth. The second one was exponential decay. All right, so the function f of x equals b to the x. And for decay, instead of b being greater than 1, it's going to be between 0 and 1. And so that's our function for the family of exponential decay with base b. Here's your general shape. It goes from left to right, it falls. So it goes down from left to right. Still passes through 0, 1. Still passes through 1b, but of course now b is between 0 and 1. The x-axis is still an asymptote for this graph. Looking at this one, the domain is still all real numbers. The range is still y is greater than 0. All right, so example 1. Example 1 says, tell whether each function represents exponential growth or exponential decay, then graph the function. Guys, these right here should be fairly easy for you because right here it shows y equals 2 to the x power. That 2 is in place of b. b is greater than 1. Is that decay or is that growth? Greater than 1. It's going to be growth because 2 is greater than 1. So that's exponential growth. Then all you have to do is put that in your calculator, write down a table, and draw your graph. So you'll notice on your graph right here, you go through the point 0, 1, and you go through the point right there. That is 1, 2, because it's 1b, and b is the 2. All right, second one right here, y equals 1/2 to the x. 1/2 is between 0 and 1. So since it is between 0 and 1, that is going to give us an exponential decay. And again, you're going to put it in your calculator. So let's put that in our calculator real quick if it'll cooperate with us. So we're just going to type in 1 divided by 2, the little rooftop, and an x. hit enter, there's my graph. If I press Control T, it brings me up a table that I can write down as well. And that right there is actually wrong. Now that I'm looking at it, be real careful. See how the exponent is on the bottom? We don't want that. So make sure, obviously an easy mistake to make. Yes, I want to delete everything. Make sure when you put that in, if it's a fraction, put it in parentheses so that whenever you do the exponent, it goes to everything. It doesn't look a whole lot different, but the table will. Okay, so y'all just make sure. And this one, the table may not have even look different because there's a 1 on top. If there's a number other than 1 on top, it will make a big difference. All right, so there's our table. And if you notice, I picked numbers that are going to give me more whole numbers. I got a half on the bottom, but I didn't pick all of the positives because most of my graph is on the left. Okay, let's look at these. It does say to graph. We're not going to spend the time to graph. We're just going to look at exponential growth or decay. Don't worry about writing all of this up here at the top. It's the same directions as you had earlier. So don't worry about that. Y equals 4 to the x. Is that exponential growth or decay? That's growth. Y equals 2/3 to the x. Growth or decay? Decay. 0.25 to the x. Growth or decay? Is 0.25 greater than 1 or less than 1? Less than 1, so it's a decay. 1.5 greater than 1 or less than 1? Greater than 1, so that is a growth. Now, just keep in mind, if it says graph, you must graph. This was just a quick little review to see if it's exponential growth or decay. On the graphing, you are just going to put it in your calculator and graph. Make sure you write a table when you graph. All right, so right here, we have example 2. We have a word problem. The value of a car, Y, in thousands of dollars, make sure you pay attention to that, it's going to be important later on, can be approximated by the model Y equals 25 times 0.85 to the t, where t is the number of years since the car was new. So the Y is in thousands of dollars, and then when we're looking at this, if we compare that to our parent function, it is Y equals, there's an A value here times B to the X. So that 0.85 is our B value that we're looking at to see if it's going to be exponential growth or exponential decay. So now it says, and I'm showing you the answer here because it's moved up, but that's okay. It says tell whether the model represents exponential growth or exponential decay. Well, that is exponential decay because 0.85 is between 0 and 1. So our answer right there is exponential decay. Now, the next one says, identify the annual percent increase or decrease in the value of the car. Annual percent increase or decrease in the value of the car. So to find the percent increase or decrease, we are going to find that 0.85. And first of all, is it going to be increase or is it going to be decrease? If I have exponential decay, it's going to be decrease. So it's not going to be an 85% decrease though. So I'm going to take 1 and I'm going to subtract that 0.85 and I'm going to get 0.15 when I subtract. That's going to tell me what my percent decrease is, and it is a 15% annual decrease. So on your decrease like that, if it's an exponential decay, you do have a decrease. You take your B value and subtract it from 1. and that tells you your percentage. Now you notice we changed from 0.15 to 15%. Does everybody know how to do that? Just move your decimal over to the right, 1, 2 places, and you get your 15%. Okay? One more piece to this. Estimate when the value of the car will be $8,000. So, when will the value of the car be $8,000? Well, Y is our value in thousands. So if I write my equation down, Y equals, what was the equation? Let's go back and look. Y equals 25 times 0.85 to the T. 25 times 0.85 to the T. And it said Y is the value in thousands. Well, if this says 8,000, I only want to take the 8. So I want Y to equal 8 because it's in thousands, and I'm going to plug that in right here. So 8 is equal to 25 times 0.85 to the T. There's a couple of ways that you can solve this. We are going to go with the easiest of those. You notice your Y is 8. You can solve this, but we're not going to go through the steps to solve it. We are going to graph. Whoops. So we're going to graph Y equals 25. Whoops. There we go. Times 0.85 to the T. Just in our calculator. And check the table. We're not drawing the graph. We're not drawing the table. We're just in our calculator, graphing and checking the table. So let's do that. Of course, it's going to be Henri. All right, so we have 25 in parentheses, 0.85. Your paper says T. In your calculator, you are going to use an X. So 25 times 0.85 to the X. Press enter. Your graph is way up here in the corner. That's okay. Just press Control T. Now, your Y value that you are looking at was Y equals 8. So we're at 21. It's going to go down. So let's go down. Whoops, I passed it. All right, when about is Y equal to 8? When X equals 7. It's 8.01. So when X equals 7, Y, and I'm going to put a squiggly equal for approximately 8. So then we can say after 7 years, the value of the car is about $8,000. So it is a word problem, but there's really not a whole lot of work to do with it because you're not drawing the graph, you're not having to draw the table, you're just checking it in your calculator. But you're writing down when X is 7, Y is 8. And you notice it wasn't exactly 8, it was 8.01. But that's approximately 8. All right, this one right here, even though you already saw part of it, that's okay. In 2000, the world population was about 6.09 billion. During the next 13 years, the world population increased by about 1.18% each year. Write an exponential growth model giving, and this is growth, giving the population, Y, in billions, T years after 2000, and then estimate the world population in 2005. So, First, we are going to write down y equals A times 1 plus R to the T. So that R is your rate. Right there. R is your rate. Your initial value is the A. So you're going to need that formula right there. Pay close attention to it. Highlight it, make a note of where it is in your notes so you'll always be able to find it. So now let's go back and plug in the things that we know. Y equals, and it said Y in billions. So it said up here we start off at 6.09 billion. Well, if we start off at that, then that's our initial value. We're going to put that in for A, 6.09. And then we have 1 plus, and it says that R is my percentage rate. Well, I have 1.18% of growth each year. So if I have 1.18%, to change that to a decimal, I move my decimal to the left. So that's going to be 0.0118. So I'm going to put that in place of R, 0.0118, and then I just have T. So to write your exponential growth equation, you're just going to add 1 plus the rate. So we have Y equals 6.09 times 1.0118 to the T. That's my exponential growth formula or equation. Now it says estimate the world population in 2005. So T is the years after 2000. 2005 is how many years after 2000? 5. So this right here, whoops. This right here tells me my T is going to be 5. So we're just going to plug that in right there. Y equals 6.09 times 1.0118 to the 5th. Plug that all in your calculator in the calculation screen, not the graph screen. When you do, what do you get? $6.45 what? So it's going to round up to 6.46. So your population is 6.46 billion in the year 2005. So you have a couple of answers there. You have an equation that you were supposed to write, as well as the population in 2005. All right, we're going to move pretty quick. This one right here says estimate the year when the world population was 7 billion. You're going to use, this is piggybacking off of the problem that we just worked on, so you are going to use the information in that and then just graph and check the table. So right here, we have Y equals 6.09 times 1.0118 to the T. The 7 billion is going to be our Y. So if Y equals 7 billion, just like the problem we did before, you're going to graph it and check the table. When you graph and check the table, and I'm going to go pretty quick through this, but X is 12, Y is 7. So that means if X is 12, that's 12 years since 2000. What year is that going to be? 12 years since 2000. 2012. So in 2012, the population was 7 billion. All you're doing there is graphing that and checking the table. Check to see when Y is approximately 12. Sorry, when Y is 7. So it'll be X is 12. Okay? All right, example 4. The amount Y in grams of the radioactive isotope chromium-51 remaining after T days is Y equals, Y equals A times 0.5 to the t divided by 28, where A is the initial amount in grams. What percent of chromium-51 decays each day? So you've got some notes over there to the side that we're going to follow along with. First, we need to write the original equation, so we're going to do that. Y equals A times 0.5 to the t divided by 28. Now, we're going to work a few things out because we have basically a power to a power. We're going to kind of undo that because we know our power should just be t, but right now we have t over 28. So we're going to separate those. Y equals A times 0.5 to the 1 over 28, and that's all raised to the t. So we're just going to separate the 1 over 28 and the t. Now we're going to evaluate that power. So 0.5 to the 1 over 28 is all you're putting in your calculator. And you have y equals A times, when you put that in your calculator, you have 0.9755, and that's to the t power. Now, this number 4 says rewrite in the form of y equals A times 1 minus r to the t. Well, I have this right here. To figure out how to write that in the correct form, we're actually going to take 1 and subtract 0.9755. That is going to give us, real quick, 1 minus 0.9755 is going to give us 0.0245. So that's what we're using in our formula. Y equals A times 1 minus 0.245 to the t. So subtract that original so you can write it in the correct format of 1 minus 0.245. It's asking you for the rate, real quick. That is your rate. So if your rate is 0.0245, write that as a percentage. Your rate is 2.45%. Write that part down right there. The daily decay rate is about this, or 2.45%. All right, here's our daily decay rate, about 0.0245 or 2.45%. Now, compound interest, A is the amount after however many years, P is the initial principal deposited, R is the rate as a decimal, and N is the number of times compounded yearly, T is our years. Our formula is A equals P times 1 plus R divided by N to the NT. Make sure you have that equation handy. You will need it. All right, so it says you deposit $9,000 in an account that pays 1.46% annual interest. Find the balance after 3 years when the interest is compounded quarterly. So A is what we're trying to find. We deposit $9,000, so that is our P for principal. R is our rate, which is 1.46%. As a decimal, that's going to be 0.0146. N is going to be 4 because it's compounded quarterly, so it's compounded 4 times. And T is our year, so that's going to be 3. Now, plug that into the formula that you just had. A equals P times 1 plus R over N to the NT, and plug everything in. So P is principal, 9,000, times 1 plus 0.0146 over 4 to the 4 times 3. You don't have to work any of that out on your paper. You're just putting that in your calculator. So let's do that real quick. Okay, so let's get to our calculation screen, and we're just going to plug that in. We have 9,000. Put your parentheses in. 1 plus control divide is going to give you the fraction that you need. 0.0146 over 4. And then make sure you're outside of the parentheses before you do your exponent, and that's going to be 4 times 3. Press enter. You get 9,402.21. So we have 9,402.21. That is going to be our balance after our 3 years compounded quarterly. So here we go. Balance of at the end of 3 years is $9,402.21. If it had not rounded correctly, you'll make sure that you round it for cents. So you'll have 2 decimal places. Make sure you either round up or leave as according to the number at the end.